Hi, my name's Robert Moffat. I'm a developer advocate at Confluent, and this is From Zero to Hero with Kafka Connect. Kafka Connect itself is part of Apache Kafka. It's the integration API for Apache Kafka. And it lets you build streaming integrations from systems upstream into Kafka topics, and from Kafka topics to systems downstream. So it means you can integrate all of these systems with their data flowing into Kafka and out of Kafka. The great thing about Kafka Connect is it's just configuration files to use. So you set up a lump of JSON and you say, I want to use this particular connector and I want to get the data from this particular place and stream it into this particular topic. There's different uses for Kafka Connect, but if you think about the applications and the pipelines that you build with Kafka, anytime you're doing integration with another system, you should probably be reaching for Kafka Connect as your first option. So some people use Kafka Connect for building out streaming data pipelines. Perhaps, as we can see here, streaming data from maybe a transactional database through Kafka and onto somewhere else to do analytics. So we want to offload that data from our transactional system, go and put it somewhere else where we're going to do our big crunching, our ad hoc analytics, our machine learning. By streaming it through Kafka, we benefit from Kafka providing the back pressure and the integration capabilities. We could add in additional databases to this pipeline, and we nicely loosely couple our consumers of the data from the producers of the data. Since Kafka stores data, we can use that same data that we've ingested from the database once, and we can write it out to other places. So we can take it to S3 in the cloud, and we can have it on premises on HDFS, but wherever we want to have that data, it's only coming from the source system once. We could also use Kafka Connect to help us with our applications, where we're writing data into Kafka from an application, and we'd like to get that data onto somewhere else. Perhaps we want to stream the data to a NoSQL store, or we want to write it somewhere else for audit purposes or for analytics purposes. Instead of our application having to take on responsibility for connecting to that target system and handling things like scaling and network problems and all the rest of it, our application just writes its data to Kafka, and then we hook up Kafka Connect, and that manages getting that data reliably from Kafka to that target system. Another pattern in which we see Kafka Connect being used is helping us evolve existing applications towards newer ways of doing them. So a lot of the time our existing applications are built with databases holding the state. So it's an existing in-house application or a third-party application, and whatever it does, it probably ends up writing stuff to a database. When it writes to a database, those are events, and we can capture those events and we can use them to drive new applications. We can say, in this CRM system that exists somewhere else, when someone writes a record, we would like to write a new application that responds to the fact that a new record has been created, or the record's been updated or even deleted, and we can capture those through Kafka Connect into Kafka and use it to drive applications. Those are some of the uses for Kafka Connect, some of the patterns in which we see it being used. So now let me actually show you in action and give you that kind of idea of how it's to use and what it's like to actually build things with it. So there's a repository called Demo Scene. This is where we put a lot of the demos that you see us presenting, and we've got one down here called From Zero to Hero with Kafka Connect. And within this, you've got a Docker Compose file. So all you need locally is Docker and Docker Compose. You can say Docker Compose up, and then you can actually follow the full script through. So I'm going to be looking at this one here, and you'll see me kind of like moving between my screens and where I'm focusing, because I'm going to take the commands from there. We're going to use that to build out this demo. And so you can see I've started the stack up already, and we've checked that Kafka Connect's available. The next thing we're going to do is we're going to check that our particular connectors that we want to use have been installed. So we go to that, and we're saying to Kafka Connect. So Kafka Connect uses a REST API. So you use it to configure it and to find out about the state. And we can use it also to find out which connectors we've got installed at the moment. After I've shown you Kafka Connect in action, I'm going to talk about how Kafka Connect actually works internally so that we understand enough as end users how we actually go about using it. I'm also going to talk about running it and kind of how we go about deploying it. So when I talk about installing connectors and stuff like that, we'll come on to that later, don't worry. So we can see we've got different connectors installed, which means that we can now actually crack on with getting some data into Kafka from our source system. So what we're going to build is an integration between a relational database streaming its data into Kafka And then we're going to take that data and we're going to stream it out to two different sinks. We're going to stream it to Elasticsearch and to Neo4j. So our relational database is MySQL. So let's launch a MySQL prompt, and you can see that's started up there. And if we say show tables, we can see you've got a table called orders. So let's have a look at that order data. And you can see within that table, you've got information about an order that's being placed. So you can see the ID of the order, we can see the value of it, what was the order for, who placed the order, when was it created, when was it updated. So I'm going to set a little data generator running. I'm just going to create a separate window here and set that running. And if I go back to MySQL now, and if I query it again and say, just show me the latest record, you can see you've got new data arriving in it. So order ID 509, order ID 519, 521. So these orders are being created all of the time and just arriving continually in this relational database. So that represents our existing application somewhere in our business, somewhere in a third party. We're going to stream data from that database into Kafka. And I'm using a database, but it could be a message queue, it could be a flat file, it could be anywhere that we want to integrate with. We're going to stream that into Kafka using Kafka Connect. So let's see on here, let's come out of MySQL. I'm going to set this running, which simply polls MySQL every second or so, and it shows us the latest record, because we can compare this to the data as it's arriving into Kafka once we've set that up. So now we'll go and create the connector. So this is the actual integration piece. This is the configuration. So it looks like this. It's quite a long bit of JSON because it's a fairly, there's lots of different things that we need to set up within it. But basically we're saying we would like to use from the Debezium project, the MySQL connector. We're going to say, here is where MySQL is, here's how we connect to it. Here's the particular table that we want to get data from, this orders table, and a couple of transformations, which I'll talk about later, but how we're going to process that data as it passes through. So we can see here we've sent that to the REST API and it says we've created it. And now we can say, well, let's have a look at the status of that particular connector. And it says the connector here, it says it's running. Okay, so the connector's running, which means we should have data flowing in to our Kafka topic. So now we can go and do this. We can actually have a look at that data. So I'm going to run a consumer here using a tool called Kafka Cat, and it's going to go to our orders topic, and it's going to show us from the data that's flowing in. Well, let me show you the raw payload to start with, and then we can actually see what else is happening. So each message that's come from the database, we can now see in the Kafka topic. We've got the order ID, we've got the customer ID, we've got the order total, and so on. So that's flowing into the Kafka topic. That's as anything changes in the database, it's going to flow straight through into the Kafka topic. Let's go back to our previous screen where we could see the output from MySQL, so the latest data as it's arriving. And I'm going to split that screen there. I'm going to do it like this, vertically. And we're going to run that same command. And this time we're going to say to the Kafka consumer, just show me the ID, the create timestamp. So we're just going to see those two fields so we can actually track as this data arrives, it's actually in sync with what's happening in the database. So if we look on the left-hand side here, we've got the database ID 834, 836. And if you look over in the Kafka topic on the right-hand side, there's 834, there's 836. So as the data gets changed in the database, it gets reflected in the Kafka topic straight away. Now, let's take that data and let's stream it somewhere else. So we've got the data flowing in from a database into a Kafka topic, and now we can push it from a Kafka topic down to somewhere else. So let's send it over to Elasticsearch. So again, we're using the REST API of Kafka Connect. We're creating a new configuration, this time with the Elasticsearch sync connector. We're taking data from this particular topic and sending it over to Elasticsearch. We say we've set that up, it says it's been created. We're also going to send the data over to Neo4j. And you'll notice for each of the different connectors we're creating, there's some standard configuration, like here is the connector class, here is the Kafka topic. And then you have configuration specific to the connector. So where is Elasticsearch? What do we want to do with the schemas and the keys? And depending on where the data is coming from and where it's going to, you'll have different configuration that you need to specify. So when we set up the configuration for Neo4j sync, again, it's the Neo4j sync connector. There's our standard connector class. But Neo4j needs to understand how it models this data. And Neo4j's got a language called Cypher, and so we express using Cypher how to model that data that's coming through from the source. And so we go and create that, and then we say let's have a look at the status of these three. And we can see here that we've got the Elasticsearch one is running. The Neo4j one has failed, which is terrible because this is a live demo or a recorded live demo. So we're going to go and check out Elasticsearch, and then we're going to go and poke around and see if we can understand what's up with the Neo4j one. So let's have a look at Elasticsearch. I'm actually going to use a tool called Kibana on top of that. So here's Kibana. We're just going to refresh some of the fields, and then we can open up Kibana. Let's open that in a window there and put that on the screen over here so that you can see it. And within this, we've got the data as it flows in to that topic. So let me put the window like that so that you can see what's going on here. And close that down and put this window down here. And now we can see we've got data flowing into the database here, order ID 118. We can see the same data flowing into our Kafka topic on the right-hand side of that pane there. And then here at the top of the screen is Kibana, which is sitting on top of the data in Elasticsearch. It's set to refresh every second or so. And as that data arrives, here's our order ID 1142, 1149. That's as the data is arriving in the database, bottom left of the page, flowing into a Kafka topic, bottom right of the page, and then over into Elasticsearch and being rendered in this dashboard within Elasticsearch at the top of the page. Neo4j, we'll figure that out later. If we get time, we'll actually fire up a bit of a debug session. But for now, I want to go back and explain more about how Kafka Connect works internally. Now, Kafka Connect is part of Apache Kafka. So part of Apache Kafka, there is an open API. You can go and look at the Java docs. You can look at the Kafka improvement proposals, the KIPs, the design documents behind it all, which as developers of plugins, as like coding this kind of stuff, that's super interesting and super relevant. As users of Kafka Connect, as developers, as data engineers, we only need to understand some of it. We don't need to dig all the way down into it for deliberate reasons, which is Kafka Connect abstracts this concept of integration for us and it exposes a configuration interface. We don't need to understand all of that, kind of like the bits and bytes all the way down there. If we want to do that, we'd go and write some separate code. But the whole point of Kafka Connect is you don't need to write that code. You just use the configuration. But you do need to understand what's happening in the pipeline that we're building. So the first piece of the puzzle is the connector plugin. Now this is the piece that speaks the specific technology with our source or target. So if we're pulling in data from a database, it speaks like JDBC, or it goes to the MySQL bin log. It speaks the actual API that's necessary to get the data in from that source system or write it down to the target system. We specify it using the connector class, and when you install the connector, the documentation will tell you the name of the connector to use. That connector is the only bit that's specific to that source or target technology. So if we're using a connector reading data from a message queue, it's going to speak the particular API for that message queue, but it passes internally within Kafka Connect a representation of that data. It passes the actual payload, the value of it, and the schema of that data. But it doesn't have anything more specific to do with that source system anymore. It's now just a generic representation of that data. Taking that data and writing it into Kafka is the job of the next plugin. And this is the converter plugin. So when we write data to Kafka, it's written as just bytes. We just write bytes to Kafka topics. Kafka is not opinionated about how we serialize that data. I am opinionated about how you serialize that data. You should be opinionated about how you serialize that data, because there are good ways to do it and there are less good ways to do it. When we take that data from a source system, it has a schema. Almost all the time, it has a schema. We just sometimes choose to ignore that fact because it makes things a bit more complicated. But they're complicated for a good reason, which is when we're building applications, when we're building pipelines, schemas act as our API, as our contract between the different pieces of the puzzle. So if we chuck them away, it makes life so much more difficult and it makes the processes that we build much more brittle. So use something like Avro, use protobuf, use JSON schema, use something where we have a schema for that data because it makes things so much better in the long run. With the schema for the data, it gets stored in the schema registry, and then Kafka Connect or any other tool that's writing to Kafka will write the message itself onto the Kafka topic. If we're using Avro, if we're using Protobuf, it's a nice small little binary representation of that data with a schema available separately. And since the schema is available separately, it means that any consumer of that data, whether it's Kafka Connect as shown here, or your own consuming application that you're writing, or something like KSQLDB, it can fetch that schema from the schema registry, it can deserialize the data, and then, so if we're writing the data down to a database, because we've got the schema, we can go and build that table automatically from that connector. We don't have to go and do it manually and find out the schema manually because we have it already from the schema registry. So the converters are a very, very important part of it. It's really worth your time understanding exactly what they are, what they do, and how to use them properly. You specify them as a global configuration in the Kafka Connect worker, and I'll explain workers later on. You specify, I would like to serialize the value for my message using this converter. I would like to serialize the key for the message using this converter. And also, when you're deserializing it, which converter do you want to use? Now, obviously, you want to make sure that you match these up. You can't serialize it using one method and deserialize it using another, because that just would not work. So if you're writing Avro onto the value of the message, you need to read Avro from the value of the message. And if you don't, you hit the kind of errors which we'll talk about briefly later on. Now, in previous versions of Apache Kafka, there was a configuration called the internal converters, which was exposed. And this caused lots and lots of confusion and wailing and gnashing of teeth, because people sometimes run into trouble with converters, and so they say, right, I've got a value converter. And then I can see there's also an internal value converter. And things aren't quite working, so I'm going to add in another one. I saw this thing on Stack Overflow, or I Googled something, and I found this blog that said I should also have a key internal value converter, and then a key internal value converter, and then things still aren't working, so I'm going to add in more and more of these things, and please just hope that something will work with these converters. Now, since Apache Kafka 2. something, it was quite a while ago now, those internal connector configurations have been deprecated, and you just specify your value converter and your key converter. The third piece of the little box of plugins that we have are single message transformations, and these are optional. When you're building a Kafka Connect pipeline, you need to specify your connector plugin, where's the data coming from or going to, the converter, how are we serializing or deserializing that data with a Kafka topic. Transformations give us a really nice ability to apply transformations, the clues in the name, to the data as it passes through the pipeline. So as we're taking data in from a source system, we could say, well, drop these particular fields. We don't want to write those to the Kafka topic. As we're reading data from a Kafka topic, writing it down to a target system, you could say, I would like to change this data type here. I would like to add in this piece of data lineage. So transformations, they're part of the configuration of a connector that you create. They're not the most straightforward things to set up, but the syntax looks like this. We say we've got the transforms prefix, so that's the transformations, and then for each one we give them a label. So we say it's going to have a date, it's going to have a label foobar. Now label foobar is a silly label to give because it tells us nothing about what it's going to do, but we've got two transformations with two different labels. Then we say for each transformation, so we've got transforms dot label as the prefix, and then each one's got a type, and then other configuration elements. So here we've got a timestamp router, which is saying take the topic name and append the timestamp with a year and month on it. And we've got one called label foobar, which if we look at it carefully is actually saying rename delivery address to shipping address. So we've got these three different plugins that we use in building out our pipelines. It's all extensible. You can write your own if you want to. So connector plugins, there's a huge ecosystem of them out there from the community, from vendors. So a lot of the time they exist already. But if you've got some new technology for which one doesn't exist, go and write it. If you're writing your own plugin, don't start mucking around with thinking my plugin must handle like I'm going to write to the Kafka topic, because you don't do that. Your connector plugin just takes the data from the source system and passes it on internally within Kafka Connect. The converter is responsible for serializing that data. So if you've got a different serialization method, you can go and write your own converter. And transformations as well. People quite often end up writing these for particular purposes. So you can get all of these off Confluent Hub. So go to Confluent Hub, type in a particular technology that you're interested in or transformation that you're interested in. So you want to transform data that's coming in as XML, you type in XML, you search for that on Confluent Hub, and you find there's a single bit of transformation that will do that for you. So that's enough of what you need to know about what's happening within the Kafka Connect box to be able to set it up as a developer, to build some pipelines and integrations with it. But then you need to run it. Then you need to actually set these things going and manage it and operate it. You could just use Confluent Cloud, where we have managed connectors, so then you just configure it and it gets run for you. But if you're running Kafka Connect on premises yourself, then you need to understand a bit how are we going to actually go and deploy that? What's the runtime look like? So we have some more terminology. We've talked about connectors and converters and plugins. Now let's talk about connectors and tasks. When we run a connector in Kafka Connect, we have this idea of a logical connector. So we've got like a sink writing data from a Kafka topic to Amazon S3, for example. That gets carried out internally with the actual runtime by a task. And you could have a different connector, you could have a JDBC source pulling in data from a database, and again we have a task that runs this. But Kafka Connect can also parallelize work within a given connector. So we might find that the JDBC connector says, actually, I'm going to run two tasks because you asked me to pull in data from two tables, and I'll pull both tables in parallel. So that's this down to the author of the connector plugin, who will say, well, I'm going to enable it to scale out if the user has allowed me to, and I'm going to do all of this work in parallel. Depending on the integration that you're doing it in parallel might not make sense. You might want to force it to be serial. So that can be configured. These different tasks are actually executed within a worker. So we're now down to the actual nitty-gritty of the JVM, of the process that we're going to run to actually run Kafka Connect. When you go to the command line and say, run Kafka Connect for me, please, you're actually instantiating a Kafka Connect worker. This is the JVM process that you'll see if you go and look at what's running on the box. It's called a worker. Within the worker, the actual tasks and stuff like that get executed. There are two different deployment models for Kafka Connect workers. There's one called standalone, and there's one called distributed. Now it's worth understanding this carefully because you may not choose the one that you might guess is the appropriate one. Standalone is not usually what I would recommend you use, even if you have a single node standalone that you want to run it on. And this is why. The standalone worker is not fault tolerant at all. If it dies, you lose your stuff. You have to kind of like revert to a backup or something like that. It's not scalable. So if you want to add in additional capacity, you have to set up a separate worker and you have to partition your connectors across them. So in this example here, we've got the JDBC source connector. It's got two tasks running within it. If you need to scale that ingest, you can't because you have one worker running one connector. That's as low down as you can go. Whereas if we run a distributed worker, the distributed worker can run on a single node. So it's like it doesn't have to be distributed to actually run the distributed worker. We have a single node running all of our tasks. But it uses Kafka itself to store its configuration and progress and stuff like that, which means that if we add in a second worker, it can find out the configuration and so on from Kafka, and it scales out beautifully. So we can now have tasks running across one or more different workers. Kafka Connect allocates that work accordingly. If we lose a worker, Kafka Connect will say, okay, we've lost something here, we need to move that work around to make sure that all of that work's being carried out. So we can scale it out as much as we want to, both for redundancy and throughput. And if you go from a single node to another node, you just add in an additional worker. Whereas if you're using standalone, and then you say, oh, I need a second worker, or I want to switch from standalone to distributed, it's a different way of configuring it, it's a different way of running it. It's just easier generally to start with a distributed worker on one node. And then if you need to scale out, if you don't, well, that's fine because it's just as easy to work with on a single node. You don't just have to build one great big cluster of Kafka Connect workers. You can, and some people do, but you will also see organizations who will partition their clusters of distributed workers. So you may have one cluster of workers that's like resilient and fault tolerant and scalable, handling one set of connectors or one business unit's work, and then a separate one running a bunch of other stuff. So it's up to you how you deploy that. And that could be running against a single Kafka cluster or different Kafka clusters. You can carve it up entirely how you want to. You run Kafka Connect as a JVM process. So you can run it on bare metal. You can also run it on containers. So there's a base image that's provided. If you go along to Docker Hub, you can find that on there. And then to install your particular connector plugin that you want, you need to install that into the container when it's actually run. Otherwise, you just have the runtime. The important thing about installing these connector plugins and converters and transformations as well, if you're using them, is that they need to be installed before the worker runs. You can't install them afterwards, which means that we need to think about how we're actually going to do this. So you use Confluent Hub usually to pull down the particular jar file for the connector or the plugin or whatever that you need. And then we can do it one of two ways. We can either say at runtime, we're going to instantiate this base image, and then before we launch the worker process, we're going to put in a little bit of code to say we'll pull down the additional plugins that we want and then launch the worker process. Or we can actually go and build our own image, which is probably the more kind of proper way of doing it, but it adds in additional steps if you're actually just doing this as like a prototype thing on your laptop. So you'll see all the demos and stuff like that we publish on Demo Scene. A lot of the time we use this pattern because it's just like, here's the base image, edit the Docker Compose YAML to add in a few more things, and then off we go. But if we were doing this thing for real in production, you'd probably end up building your own images. You can also automate creating the connectors themselves because you create connectors by using the REST API. So you can actually put that into your Docker Compose also, or into however you're deploying your containers. Now, I mentioned we'll talk a little bit about troubleshooting as well, because we've seen what Kafka Connect's for. We've seen how to go about configuring it and understanding it from an end user point of view. We've seen about understanding it from an operations and runtime point of view. But now let's think about it like, well, what happens when things go wrong? Because things do go wrong, let's be realistic. There's different concepts within the runtime that we've talked about. We've talked about workers and we've talked about tasks. And one of the first things that throws people off is that you build something out and you've deployed your configuration. It says, yes, I've got the configuration and things are running, but I've got no data. Why is there no data flowing between my source and my target? And you go along to Kafka Connect and you say, I'm going to use the REST API to say, what's the status of this connector? And it says the status is running. And you think, well, where is my data? If you drill down within the status, you find that each task has its own status. And if the task is failed, if all the tasks are failed, you're not going to get any data. So you have this concept of like it's logically running, but in practice, the connector isn't running. If all the tasks are failed, you're not going to get any data. So to then troubleshoot it further, a lot of the time you're going to end up going down either into the log itself, or you can also use the REST API to pull out some of the status information and get the stack trace that way. But if you don't get to it straight off the bat, so like the example we've got here, it's actually showing what the problem is, and we've got that through the REST API. A lot of the time, though, we end up going down into the log. Where you get the log from depends on how you've deployed Kafka Connect. Did you deploy it using the Confluent CLI? Is it using Docker? Is it just on bare metal? One of the really useful things that was added in Apache Kafka recently was dynamic log levels. So if you've got a Kafka Connect worker running, and you're having problems with a connector, you're not quite sure what's going on, you can actually change the log levels dynamically as it's running and also targeting specific loggers. So if you set all the logging to debug or trace, you just end up with screenfuls of stuff that you can't find anything in. It's like a full load of haystacks with no needles to be found. But you can say, well, I'm interested in this particular logger, like just for a particular connector, just for particular connectors, specific operations, and you can set those up to debug or trace, which makes it really much easier to find out what's going on. Now, sometimes the connectors go wrong and you need to go and troubleshoot them like this. Sometimes, though, you end up with kind of like logical problems in what you've built. So Kafka Connect supports the ability to do error handling when it hits messages that it wasn't expecting, and also to write messages out to a separate area if they've hit a problem. So a dead letter queue is what we'd call it. Here's an example of how you would use that. So a very, very common error that people have with Kafka Connect is unknown magic byte, which sounds fun, but I promise you it isn't. The TLDR, too long didn't read, of this particular error is that you're trying to deserialize data using the Avro converter, and the data it's reading is not Avro. That's what that magic byte thing's referring to, the Avro kind of like wire protocol. But let's look at this in a bit more detail. So let's say we've got a topic on Kafka and the messages are in JSON. We've written them using the JSON converter, and then we set up our sync connector to read them from the topic using the Avro converter. It's like, well, you can't do that. You can't read JSON using the Avro converter. It'll throw that specific error there. It just doesn't make sense. So the solution here would be to say, well, we'll just use the JSON converter for the sync, and then it works as it should do. What about, though, if you think, well, I'm supposed to be using Avro, and I've set up my Avro sync converter, I'm writing Avro messages to the topic it's reading from, I'm still getting this error. A lot of the time, particularly when people are starting out with a Kafka Connect pipeline, they'll inadvertently write non-Avro data to that topic. They'll be like trying out a particular configuration and writing a bit of JSON to that topic, trying out another bit of configuration, writing some Avro, trying something else out, and you end up with a bit more JSON on the topic. So the topic ends up with a mishmash of things. And if that Avro converter reads a message that's not Avro, it's just going to stop. So let's look at the different behaviors that we've got within Kafka Connect for handling this. So by default, Kafka Connect will fail fast. It'll hit a message. If it has a problem with that message, it'll say, nope, I'm done. I'm tapping out. I can't process it. We stop. Which sometimes is very useful if you want to make sure that you're not having any data going through which you really shouldn't be there. Sometimes, though, you just want the damn thing to work. So you say, well, if I hit an error, we've got this errors tolerance setting. Errors tolerance equals all. If you hit an error, screw it. We don't care. Just let it be. Which in itself means that things keep on flowing, but perhaps that's not a great way to do things, just ignore errors as they happen, because they could be indicative of a real problem somewhere, like you've got duff data coming through that you're completely unaware of. So a much better approach is to say, well, if you hit an error, don't stop, because we want the rest of the good data to keep flowing through, but write that bad message or bad messages to a separate topic called a dead letter queue. So that dead letter queue has now got, in our example here, JSON messages on it. We're reading through, we're reading Avro messages, this is all good. We hit a JSON one, we don't stop, but we write that JSON message out to the dead letter queue, and then we carry on processing. We can then take that dead letter queue, which is just a Kafka topic, and we can say we're going to process it using our sync connector, but we use the JSON converter this time. So now we can read JSON and Avro from that source topic. First off, we try and deserialize it as Avro. If it fails, we write it out to a new topic, the dead letter queue, which we just process as a source topic with our sync connector. And we say we'll use the JSON converter this time, and we try and process them that way. There's a bunch of monitoring that you can get out of Kafka Connect. You can use the REST API to go and check on the status of connectors. You can also use Confluent Control Center, or Confluent Cloud's got a web interface, to look at the rate of throughput that you're getting on things, to look at the lag that you've got on different topics as they're being consumed by Kafka Connect. There's also JMX metrics that are exposed, so you can get a bunch of low-level information here. You can do things like, we're using a dead letter queue, we're not expecting messages on the dead letter queue, so let's look at the JMX counter for dead letter queue, and if we see the rate going above a certain threshold, we can start to sound sirens and page people and say, well, maybe there's something broken with our pipeline. So there's different monitoring available with Kafka Connect. So hopefully you found that useful. Hopefully you found it informative. Kafka Connect is part of Apache Kafka. It lets you do streaming integration between source systems and target systems. You go to Confluent Hub to download the connector plugins and converters. You get connector plugins from the community, from vendors, from all sorts of places. It lets you integrate with all of these technologies that you want to stream into Kafka and out of Kafka. To learn more about Kafka and Kafka Connect and Kafka Streams and KSQLDB and all sorts of stuff in the Kafka ecosystem, head over to developer.confluent.io. And if you have any questions and want to join in the community, head over to our Slack community group. There's thousands of people there. It's a very warm and welcoming place, and I hope to see you over there soon. Thank you very much for your time.